All right, we're back. We're going to be on page 5 of Notes 21 of Calc AB. We're now doing volumes of revolution, which are not to be feared, right? So a volume of revolution is a volume that you get when you revolve a region around some line. All of our lines are going to be vertical or horizontal because it's way more complicated if that's not the case. And we're just kind of getting into it right now. So let's see if we can do this. So we want to find the volume of the solid form by rotating the region bounded by the curves y equals 2x, y equals 0, and x equals 2 about the line first y equals -3. All right, so there's kind of an issue. It's not really an issue, but when we revolve this region around this line, there's going to be a giant hole. And so really what we're going to do is we're going to find two volumes and subtract them. We're going to find what would happen if we rotated this and didn't have a hole. And then we're going to figure out what happens when we rotate this and don't have a hole. And then we will subtract the big volume from the little volume. That's our game plan. We want to do big volume minus little volume. So here's what we're going around. And we're going to try to do big volume minus little volume. To find the big volume, there's going to be a big radius. And I like to draw them in. So this is going to be my big radius from the axis. All right, that doesn't make any sense. I don't know. I don't think I could do that if I tried. So I'm not really sure like what it is that's happening there. There's a lot going on here. All right, so that's going to be my big radius, like capital R. And then there's also going to be a smaller radius that's going to go from the axis to the inner curve. So there's an outer curve and there's an inner curve. And what do I mean by that? Well, when you go around this, you take this region around it, one of these things, this thing is going to be on the outside of the solid that you get. So this is the outside. So that's the outer curve. And then the inner curve is this because it's going to be on the inside of the solid that you get. So there's an outer radius, an inner radius, an outer curve, an inner curve. And so for us, big R is just going to be 2x minus -3. What the heck? Why? Well, take any y value here, which is found by doing 2 times whatever x is. And then to get the distance from this point to this point, I have to do top take away bottom. There's that top take away bottom idea again, always. So that's going to follow us forever. Top take away bottom. To get the little volume, I have to do whatever y value I get here, which is just 0, and then I have to subtract whatever I get here, which is -3. So that's going to be top take away bottom again. And in this case, it's going to be 0 minus -3. So little r is just 3. And then our volume, so we can actually do it in one shot. It's going to be pi, the integral from 0 to 2 of big R squared. So that's going to be 2x plus 3 squared. Now if I put a dx, okay, I'll just do it. So this is my big volume. Then I'm going to subtract off my little volume. This is not really how I would normally do this, but that's okay. Like little r squared. Now you notice they have the same bounds. They both have a pi. So what we end up doing is this. We do pi, the integral from 0 to 2 of big R, big R squared minus little r squared dx. I came to putting parentheses around the integrand later in life. I didn't used to do that. I used to just like put the integral sign, put the dx, and be like, those are grouping symbols. It's totally fine. Now, for whatever reason, I always put parentheses around it. I don't know if the calculator like pushed me to that or what. I don't really know. I'm just going to use calculator to get that answer. So what I'm actually going to do is set up the next one. And then once we've set that up, I will go to the calculator and do all of them. All right. This time we are going around y equals 5. So put a little circle arrowy thing. Let's draw in our big radius. So as this region goes around this curve right here will always be the outer edge. So the big radius is going to be the length of this. So I'm going to draw it in. So this is right there. That's my big radius. And the big radius is going to be top takeaway bottom 5 minus 0. So the big radius is just 5. And then I'm going to get a little radius. So drawing these lines, like everybody does it. It kind of prevents you from making mistakes. You know, you don't have to think as hard. So it's going to be top takeaway bottom. So 5 minus, the equation of that line is 2x. All right. And now I'm going to do this in one shot. So it's going to be pi, the integral from 0 to 2, because that's where, those are all the x values that you can plug in to get your big radius, to get your small radius. So 0 to 2, big R squared minus little r squared dx. And remember, you're just doing a big volume minus a little volume. Always, you're always doing big volume minus little volume, however that plays out. I'm gonna use a calculator to get these answers. It's really like the answers are kind of inconsequential because like, what does it mean anyway? You know, it's all about the setup. Once you set it up, can you use a calculator to get it? So here we go. So integral, I forgot pi already. Pi times the integral, we're going 0 to 2. Quantity 2x plus 3 squared minus quantity 3 squared dx. 104 pi over 3. We could get that by hand. It's not like terrible, but again, I don't think it's really the point. And then what I'm going to do is kind of borrow this and just delete out all of that and put in what I got. So it's 5 squared. That's big R squared minus quantity 5 minus 2x, which is little r squared dx. 88 pi over 3. One thing I'll say about volumes is I personally have like no sense of what's reasonable. So like I can never really tell if a volume is going to be bigger than another volume, smaller than another volume. Like I don't know. I mean, because as I mentioned previously, I'm not super good at picturing the shapes that I'm getting. So like to know if they have more volume or less volume, I don't know how I would go about doing that. So I have to calculate it. All right. Here's sort of the generalizations that you've probably been hoping for. So for all problems, what you are going to do, sketch the region. You are then going to identify the axis of revolution. And how do you do that? You're going to draw a little like loopy thing to show that that's what you're going around, right? Then you're going to want to find the outer curve and the inner curve relative to the axis. The outer curve is going to, why is this happening to me? Why is this happening to us? The outer curve is going to be big R. Well, okay, so the outer curve isn't really big R, but that's where big R comes from. So I'm going to say it comes from. And then the inner curve is where little r comes from. Okay, and then once you have those, you're going to find the volume. So in general, you can say this, and this is how I always think about it. And until you're amazing at it, this is like a great way to think about it. And even when you're amazing at it, it's still a good way. So what you're going to do is outer curve minus axis squared. That's always going to be the big R. And then minus inner minus axis squared. That's always going to be little r squared. So technically, it doesn't really make a difference if you do outer minus axis squared or axis minus outer squared, because when you square them, you get the same thing. I always try to do it so that you get the positive radius. But again, it doesn't really matter, but it kind of matters to me. So if you're in my class, I'd prefer that you write a positive radius. So always do top takeaway bottom. That's always going to give you the positive radius. All of these are with respect to x. We're eventually going to talk about with respect to y, but just keep it in mind, right? So in some ways, we could say that big R is going to be outer minus axis or axis minus outer, depending on which one's positive. And we can say that little r is going to be inner minus axis or axis minus inner, depending on which one gives you a positive. So you want a positive radius, but it doesn't make a difference which one you actually do numerically, because when you square it, you get the same thing, right? 3 squared versus -3 squared, they're both 9. It doesn't make a difference. All right, that's the generalization. This is, you need to have this memorized and also preferably understood and conceptualized as well. But for a start, I would settle for memorized. All right, so I will be back in the next video and we will keep going. I find finding volumes to be kind of fun. It's like a good little challenge to set them up. I really like problems that say set up and then use a calculator, or set up but do not evaluate. And you get a lot of those with volume, so that's part of why I like them so much. All right, so I will see you in the next one.